Let us understand the combustion in CI engine. Now, in case of CI engine, we know that only air is taken inside the combustion chamber and the fuel is injected in the combustion chamber once the air will acquire certain temperature and pressure. So, in CI engine, for a given speed, irrespective of the load, an approximately constant supply of air enters in the cylinder. With change in load, the quantity of fuel is changed. So the air quantity remains same, but the fuel quantity changed, which changes the air fuel ratio. The overall air fuel ratio may thus vary from 100 is to 1 at no load to 20 is to 1 at full load. The poor distribution of fuel and its limited intermixing with air results in objectionable smoke if operated near chemically correct air fuel ratio, that is 14.5 is to 1 for diesel. As in case of petrol, we learnt that 14.5 is to 1 is the chemically correct air fuel ratio. But in case of diesel, the thing is different. Hence, CI engines are operated with excess air. Okay, so the ideal air fuel ratio for the diesel engine may vary from 20 is to 1 to 23 is to 1. That is excess air, 30 to 50% more air compared to petrol engine. So diesel engines are also termed as lean burn engines. Now, as we have seen the stages of combustion in petrol engine, we'll also see the stages of combustion in diesel engine. So the first stage is ignition delay period, during which some fuel has been admitted in the combustion chamber but has not yet been ignited. The ignition delay is counted from the start of the injection to the point where P theta curve separate from the pure air compression curve. The second stage, rapid or uncontrolled combustion. In this second stage, the pressure rise is rapid because during the delay period, the fuel droplets have had time to spread themselves over a wide area and they have fresh air all around them. It is counted from the end of delay period to the point of maximum pressure on the P theta diagram. About one third of the heat is evolved during this stage. The third stage, that is controlled combustion stage. At the end of second stage, that is uncontrolled combustion stage, the temperature and pressure are so high that the fuel droplets injected during the last stage burn almost as they enter, and any further pressure rise can be controlled by injection rate. It is counted from the point of maximum pressure to maximum cycle temperature. About 70 to 80% of the total heat of the fuel is evolved during this period. The fourth stage, that is after burning stage. Because of poor distribution of the fuel particles, combustion continues during part of the remainder of the expansion stroke. This afterburning can be called the fourth stage of combustion. The duration of afterburning phase may correspond to 70 to 80 degree of crank travel from top dead center. Total heat evolved by the end of the combustion process is 95 to 97%, and 3 to 5% of heat goes as unburnt in the exhaust. So the diagram very well explain all the stages. So the very first stage here is the ignition delay. Here the injection start, but still there is delay in ignition. Once the ignition start, this is the stage of uncontrolled combustion where the pressure rises up to 80-85 bar. The third stage is controlled combustion where the combustion is still continuous but the pressure slightly lowers as the exhaust stroke start. And during the exhaust stroke there is one more stage, that is after burning stage. So stage 1 to 2, this is the delay period. 2, uncontrolled combustion. 3 is controlled combustion, and number 4 is the afterburning period. So this is shown on the P theta or P crank angle graph. Now, what is ignition delay period in case of CI engine? In case of SI engine, it is very different. But in case of CI engine, what is ignition delay period? Ignition delay is the period during which some fuel has been admitted but has not yet been ignited. It is counted from the start of injection to the point where P theta curve separates from the pure air compression curve. The ignition delay can be roughly divided into two parts: physical delay and chemical delay. In case of diesel engine, what is physical delay? The period of physical delay is the time between the beginning of the injection and the attainment of chemical reaction condition. In the physical delay period, the fuel is atomized, vaporized, mixed with air, and raised in temperature. Chemical delay. In this period, pre-flame reactions start slowly and then accelerate until local inflammation or ignition takes place. At high temperatures, chemical reaction is quicker and physical delay is longer than chemical delay. Factors affecting the ignition delay period. Factor number one is fuel. Lower self-ignition temperature means lower delay period. Higher cetane numbers means a lower delay period and smoother engine operation. Intake temperature. Increase in intake temperature would result in increase in compressed air temperature, which would reduce the delay period. Compression ratio. Increase in compression ratio reduces the delay period and it raises both temperature and density. Type of combustion chamber. A pre-combustion chamber gives shorter delay compared to an open type combustion chamber. Injection advance. Delay period increases with increase in injection advance angle. With increase in injection angle, pressure and temperature are lower when injection begins. Diesel knock. Now these all are related to the normal combustion. Now we will starting with the diesel knock, which is related to the abnormal combustion in case of diesel engine. We'll see it in next class. Thank you.